Okay, let's get started with questions 1 through 3 on exam 2. Question 1, find the derivative of root 1 plus x. Before doing any of these, it's easiest to differentiate when you have it written like this. So f of x equals 1 plus x to the 1/2. That way you can use the derivative rules that we've discussed plenty of times. So if you were to differentiate, the rule is you'd bring down the exponent, so bring that out front, leave the inside alone, differentiate, then subtract 1 off the exponent, so 1/2 minus 1 is negative 1/2. And then you'd multiply by the derivative of the inside. And the derivative of 1 plus x is just 1. And then you can clean this up a little bit. You can leave it like this, but clean it up and it looks like this. So that's our derivative. Question 2, for what value of x will this exist but not be differentiable? Okay, so where does this exist? Well, this exists where 1 plus x is greater than or equal to 0, which means x has to be greater than or equal to negative 1. That's where this function exists. Now, where is it not differentiable? If you take a look up here, it's not differentiable when, well, same thing. If you have a radical, we need to make sure that x is greater than or equal to negative 1. But if it equals negative 1, what happens? This becomes 0. So this has to be x greater than negative 1. Because if it equals negative 1, then you're going to be dividing by 0, and that's bad. So notice the difference. The original function exists on this interval, but I'm only differentiable on this interval. Therefore, for what value of x will it exist but not be differentiable? When x equals negative 1. Okay. And final question. Explain why the absolute value of x is continuous everywhere but not differentiable. Now, since I'm saying explain, you don't really have to be too formal about it. Now, just to show you what's going on, if you were to take out your calculator and figure out what the absolute value of x looks like, that way you have an idea. Looks like that. Notice that the absolute value function is the v. It's a diagonal line going down to the origin. At the origin it turns and it goes back up. It's continuous everywhere because the limit exists everywhere and the y values exist, and the limits are always the y value. Now, we go and actually define the absolute value of x as this. Okay, that's what this is. Both of these are polynomial terms, so they're continuous everywhere. But why are we not differentiable? So this is f of x. You can explain this. I mean, all you got to say is that it's continuous everywhere, but it's not differentiable because it has a corner. Okay. I mean, we can zoom in. Turned off on me, but it looks like this. And that's now what's happening? Why is there a corner? Well, if you were to differentiate this function, the derivative of x is 1. And the derivative of negative x is negative 1. So what's happening here? The derivative says when x is approaching 0 from the right, we should have a slope of 1, which we do, slope of 1. And when we're approaching 0 from the left, we have a slope negative 1. So what happens at 0? Well, at 0, we don't have a slope to work with. Because coming in from the left, we're negative 1. Coming in from the right, we're positive 1. So no derivative exists. Saying derivative does not exist at x equals 0. And hopefully you can see why. Okay, the corner means it's a sudden change in the slope, a drastic change. We're going from -1 to +1. So there's no slope at the origin. Now again, all you'd really have to say is it's continuous, it's not differentiable because it's a corner. We had a couple different types of discontinuities, or not discontinuities, reasons why something is not differentiable. Let me just quickly go over some of those. You are not differentiable at corners. Okay, corners would be something like this, right there. Vertical tangent lines. A function like cube root of x. Right there, on the cube root of x, the tangent line goes vertical at the origin. Just for that moment, but the tangent line would go vertical, so no derivative exists there because the vertical tangent line. And just general discontinuities. If you're not continuous, you're not differentiable. It could be because it jumps, so maybe no slope can exist at a point if it's jumping at that point. So hopefully this helps. So that's questions 1 through 3.